Today on the IoT Show, Andrew Liu will tell us everything we need to know about Cosmos DB and how to use it in an IoT application.
This is going to be a really great session. I'm really looking forward to having you attend.
Hi everyone, you're watching the IoT Show. I'm Olivier, your host. Thanks for coming back. Today we have Andrew from the Cosmos DB team.
Hey everyone.
Who's here to tell us everything about Cosmos DB and why should you care as an IoT developer. Andrew, thanks for coming to the show.
Yeah, I did. It's awesome to be here.
Yeah,
so
can you tell us a bit about yourself? Who you are, what is your team doing at Microsoft?
Sure. I'm a PM on the Azure Cosmos DB team. I've been on the team for about the last 5 to 6 years now. I've been working on everything from programmability to launching our service from preview to GA to V2.
Awesome.
It's awesome.
And we're discussing just before starting the recording that your audience, your customer is the developer using Cosmos DB, right?
Yes.
Okay, so you're going to tell us everything. Crash course on what is Cosmos DB. We are IoT guys, so we don't know much about what's going on. And there's like so many storage solutions for different reasons on Azure that we really want to understand what is Cosmos DB, when should we use Cosmos DB, especially in the context of IoT scenarios.
Oh yeah, absolutely. So yeah, let's dive right in. The way I like to think about this, we kind of have this like house diagram. It's like laying out the foundation and then kind of looking at it as like a layer cake. But in a nutshell, Cosmos DB is a distributed database. What I mean by a distributed database is it runs on a cluster of machines as opposed to a single machine.
Okay.
So that's going to be a core concept that you see scale out. And really, in a nutshell, we scale out in 2 dimensions. We both shard and partition the database. That allows us to get really ability to ingest really large amounts of data, as well as a really high rate of data. We also replicate the data. That gives us a lot of redundancy, so that if a machine dies, the system fills over seamlessly and is highly available. We also see people use the replication to kind of bring CDN-like capabilities to a database where rather than rely on caching, we're doing active live replication across regions. We can even do so in multi-master. So beyond availability, people are doing this from a really low latency perspective. And so this kind of gives us, fleshes out the bottom core foundation. So I like to make an analogy. Think of Cosmos DB almost like you think of .NET. .NET's got a back end. That back end is going to run on some bytecode. It's got a runtime, and it can expose it through various different ways of programming against it, whether it's C# or F#. Same thing in Cosmos DB. We have a backend that has this uses the replication for turnkey global distribution, that partitioning for elastic scale-out of storage and throughput. We do this as a fully managed service with our own resource governance layer to give you predictable low latency, as well as from a replication standpoint, one of the things that what really makes a global distribution work is the fact that we can do this in a multi-master way with consistency guarantees. And then finally, as a fully managed service, we have a bunch of comprehensive SLAs. And that'll actually lead into why people are using this. And think of this as the back end. Then we have a front end. That front end allows us to go and understand different protocols, ranging from our own SQL API to open source APIs like the MongoDB and Cassandra and Gremlin APIs, where you can target existing Mongo and Cassandra applications to Cosmos DB without really having to rewrite any code. Okay,
so like ingest super fast, lots of data, and low latency to access the data. Does resonate to me as an IoT developer, right?
Yeah, so we tend to see this in IoT in 2 core scenarios. One is the device telemetry. And like we all know this from a big data perspective. People like to joke like, oh, Facebook or Twitter is big data, so many users. But honestly, like, I'm not that active on social media. I might tweet a handful of times a day. Meanwhile, our devices... You're going to
tweet about this IoT Show episode, though, right?
Oh, yes. I'll definitely be tweeting about this one.
You better.
But, I mean, looking at our devices, they're going, here's my state, here's my state, here's my state, here's my state. In 10 seconds, it's produced more data points than I can, as a human, do all day. And when you have fleets of tens of thousands of this, so for example, one of our users is ExxonMobil. They're tracking 50,000 different oil wells all around the US, making sure that their oil wells are healthy. They're tracking the flow rate, the temperature, making sure everything is healthy. You basically have this problem of I have lots and lots of writes per second coming in. And there's several ways of solving that. Historically, what you would do is if your database can't cope with that, what you would do is you put a stream processor and take many data points and turn that into one data point, an aggregate, right?
Yeah.
But the challenge with that is fidelity of the data. What happens when something is an anomaly happens? Like the max or the average temperature goes up, and you're wondering, where's the raw telemetry? Can I actually get a fast indexed data store that can ingest the semi-structured sensor data at a high rate and provide queries? And so this is why we see device telemetry land on Cosmos DB a lot. It's really just the partitioning and automatic indexing on what makes it pop. The other side of it is we see it a lot in device catalogs. People are using our replication. And if you look at cloud services, we typically look at availability by measuring the number of nines. So some data stores have 3 nines, some have 4 nines, some have 5 nines. For Cosmos DB, we're actually at the very high end of that, the 5 nines.
Okay, nice.
So if you're doing things, we have big automotive manufacturers where on an assembly line, they have little robots running around, and they're driving commands to each one of these robots. To flush that state, what they wanted to do was they wanted something that was extremely highly available, so that way the assembly line never stops. And from that catalog perspective, we typically see Cosmos DB use that mostly for its extremely high availability.
Okay, that makes sense. And from the IoT developer's perspective, Cosmos DB would be actually sitting in the back end. You would ingest the data from the devices through IoT Hub. Then you will certainly transform the data using functions, stream analytics, and then put that into Cosmos DB, right?
Right. And so here on the example on the architecture diagram, this is actually from ExxonMobil.
Okay.
Their oil wells, their gas compressors, their pipelines, everything comes into Azure IoT Hub. Typically, you might position like a hot store and cold store. That way, you get the blend of both fast interactive queries on something that's very hot, and Cosmos DB is typically the serving layer there.
Got it.
And likewise, if you're using something like Azure Time Series Insights, I mean, this is more for interactive when you have a small dev team doing like reporting, BI on it, but not really driving like a programmatic like REST API to serve your mobile and web app.
Okay, got it. Yeah, so multiple services, multiple usage, and yeah, Cosmos DB definitely like for that hot pass was heavy analytics that's going to happen behind it, right?
Yes, yes.
Okay, love it.
So in terms of what every developer needs to know coming into Cosmos DB, what I want to do is I want to separate out. There's some things that are must know and some things that are nice to know.
Okay.
Must know are things like the partitioning, request units, and in the context of IoT are TTL and change feed. I'll explain what these are. Nice to know is things like, for example, how you tune the index policy. Because ultimately, changing the index policy, you can change after the fact. It's very easy and light to do so. But some of these things like partitioning, if you get that wrong early on, you know, it's a bit harder to change. So what I'll do is I'll jump into an actual demo, show you what Cosmos DB looks like, and talk through some of these concepts.
Let's go.
So here I'm in the Azure portal. I'm on my own Cosmos DB account. And whenever you create a Cosmos DB, this is the first thing you'll see in portal.azure.com.
Okay.
And if I go to the Data Explorer, what I've done here is I've set up a device catalog and a device telemetry store here. And just to kind of show you what the system looks like, I'm ingesting a bunch of telemetry into my Cosmos DB.
Okay.
And what I've done is I've set up a VM to just pound the database. So what it does is it spins up a bunch of threads.
Okay.
And in each one of these threads, it runs in a tight loop, just pound the database, write lots and lots of data to it.
You're doing what the, as the PM, you're doing what the devs don't like, which is actually using the service and trying to hurt it.
So let's go and run this piece of code real quick. Initially, what I have here is a telemetry store set up at 10,000 RUs. And RUs is just, think of it as our compute unit. And so as we scale out, we can scale out to infinite number of RUs to get you as much write ingest as you need. So this is going to be the currency, which you think of both from a performance, especially a throughput perspective, as well as a cost perspective.
Okay.
Now, this is really good to understand. And one of the neat things about Cosmos DB is, let's say I have this system where I'm writing about 1,000 writes per second. It uses about 10,000 RUs per second right now. What if I find that, hey, the business needs to go and deploy, you know, at 2x more sensors or 5x more sensors? One of the cool things about Cosmos DB is we can actually scale this out without any downtime. And that's, I think, one of the things that's a little bit unique to this. And one of the things you'll want to actually think about is, in terms of using RUs, you want to do it dynamically. So example, if you're doing batch jobs off of Apache Spark on top of Cosmos DB, at the beginning of the batch job, you might ramp up the RUs, do the batch job, then at the end of the job, ramp down. And so now that we've scaled this up, I believe it was 5x to 50,000 RUs, what you'll see is this little app here. I think the app is actually the bottleneck here, but it's going to ramp up and converge up to 50,000 RUs as it spools up.
Okay.
And just like that, I mean, this is how scaling works in Cosmos DB.
So you've done that manually. So is there a way to automate that scaling?
Yes, you can do it all through programmatic APIs. And in fact, if you're doing batch jobs, I would have a setup and a cleanup step that calls our APIs to do this programmatically.
Okay, yeah, because I can see that once again in the IoT scenarios where you were saying the scenario like I have that many devices and then I know I'm going to have a specific event and suddenly I'm going to have a huge amount of devices connecting or more data actually incoming, in which case actually you will have to have that scaling that happens. Scaling is also about optimizing cost, right?
Yes, it's all about optimizing cost and performance. Both are deeply tied. Basically, RUs, think of it as how many compute units you are buying. Yeah. The more compute units you buy, the more throughput you'll get, but the more cost the solution will have as well. Obviously. So deeply tied concepts. So what's neat about this is if I flip over to the Cosmos DB, the collection, not only are we ingesting things at a very high rate, let's say you have a Gen 1 device and you're about to do your Gen 2 device. Yeah. Historically, if you've sharded your own data store, you're thinking about how to do schema management. But in this case, software moves a little bit faster than hardware. You're probably not going to go back to all your Gen 1 devices and add that additional telemetry. So let's say here that I'm going to add another field. Like in this case, I might add, let's say, a flow rate to this telemetry. Okay. And let's say for this, I actually fill out a value. This is just a demo data set. But I have a flow rate of, let's say, 50. Cool. So now that we've added a new field, we can use the automatic indexing capabilities and query this dynamically on the fly. So here, if I look at the message schema, look at its fields, and look at the flow rate, and look at something that's, let's say, flow rate greater than 40, right there, without any alter tables, create index, I can go and add properties on demand, query across that in real time, and do so with very low latency.
I can tell you that for someone coming from the non-data world and the IoT world, like I'm always scared when I started playing with databases and indexes and queries. That reassures me. Yeah, I like that.
It makes it super easy to use. So let me pause this workload real quick, and I'm going to show you a second workload. So I'm going to show you a demo here. When we talk about queries, how fast are these queries? So what I'm doing here is in just a while true loop, I'm going to go and run a query, and I'm going to set up a stopwatch and look at just how fast our queries are in Cosmos DB. So if I set this up, you'll notice that once the client starts up and loads the topology, caches everything, to know how to initialize and connect to the database, I can run live queries in it and consistently get under 10 millisecond latency. So when we're talking about real time, everyone likes to say real time. It's all about how real time. Is it an hour, a minute, a second? In this case, we're talking about milliseconds.
And in addition to the speed, actually real time, and that's a notion that is dear to my heart because I used to develop real-time embedded systems. It's not that much about the speed. It's about the notion that you can predict it's going to be less than that. You can count on that service to give you that answer in that less than 10 milliseconds.
That's correct.
And you guys have SLAs in place as well. So that means that for the customers, there's that reassurance that by using Cosmos DB, you're going to get these answers that fast.
That's correct. And so what we see is scenarios like, example in vehicle telematics, where we see our users building solutions like, hey, when an airbag gets deployed on a vehicle, immediately pick up the phone and call that driver. Hey, man, are you OK? And these are things that are very time sensitive. Like, I don't want to call you an hour later. And that's the thing, right? Like, if they answer, good, and then I can calm down. If they don't answer, then you can go and live query, hey, where are the GPS coordinates? Let me get emergency services on site right there, right then.
Yeah, definitely hence the notion of hot pass on your Lambda architecture.
Absolutely.
Love it.
So things you'll want to know, in order to achieve this scale out, Cosmos DB does a lot of the heavy lifting in terms of scaling out this workload across a set of machines. But the main thing is you're going to need to tell Cosmos DB a logical hint, how should I distribute that workload? And so a lot of people tend to get this part wrong. When you create a new container or collection, it's going to ask you for this thing called a partition key. And that's what we're going to partition that data on. Intuitively, some people might think, oh, over time, I'll have a pretty good distribution of data, so they might choose current time. But what they miss is at any given point in time, all of your sensors have the exact same current time value. So this loads all of the requests on a single partition, and that partition's running blazing hot. Meanwhile, the other partitions are left idle. In IoT scenarios, typically the natural key is going to be the device ID. Your workload's going to grow as the devices grow. And this is going to be a much more natural starting point. So understand that how to choose a good partition key. And sometimes if you have devices that get really large, you might even form a composite key, like concatenating the device ID. Time might not be a good in isolation, but it's actually a very good candidate for a composite key. So like do the device ID plus the current year or current month.
Makes sense.
You might also want to tune the index policy later on. Indexing, what we do is we can automatically index any new property. If you have really, really large telemetry, like the sensor payload, if you tune this, you'll find that the RU cost for each one of the writes is going to be much, much more friendly. And what's kind of neat here is we have, instead of a whitelisting approach, you can do a blacklisting approach. So from a whitelisting approach, you might index /star, so index everything by default, but more specific paths, like maybe I know I'm never going to query off of this e-tag or different other properties. I can save some RUs by actually blacklisting a few fields here. And then another thing I want to show you is this time to live. In IoT, if you're using a hot store, a lot of times what you're doing is maybe it's the last 30 days of telemetry, 90 days, 1 year, that you're really going to be querying off of. You can turn on a time to live and set how much time you want to save data. So for example, if I want to do 30 days, I'd convert 30 days times 24 hours in a day, 60 seconds in a minute, plug that how many seconds I want to save that data for. And this is actually one of the #1 cost savings. In most telemetry stores, you're paying the IOPS for both the write as well as the delete. In this case, we actually do the TTL for free. So you only pay for the writes,
so
the deletes come for free.
For free, got it. So typically in a scenario where you have these IoT data, if you want to have this hot pass like with Cosmos DB, you would have to think also for the long-term storage, I'm going to use something cheap. That actually just like done a dumb thing in there, and because it's going to be post-mortem anyways, I don't need the super fast access, so I can definitely go on some cheap solution.
So you do a hot store, cold store. The TTL will give you a way of managing retention on the hot store. Today, we tend to see people use things like storage or data lake for the cold storage. What's kind of cool coming soon on our roadmap is a Spark API with automatic archival to a cold store. So we'll actually have this as an out-of-box feature.
So in parallel, love it.
And then the last thing to note is change feed. If you want to do incremental sourcing of the events, let's say the telemetry coming in, what you can do is you can actually, we bring message queue-like semantics to the data store. It's not a message queue, it's still a database. We persist everything, we index everything, but you can get fast incremental reads. And typically the advantage of using this approach is if you need a single source of truth for eventing off of, that you want to avoid the consistency problem of, hey, I successfully wrote to data store 1 but not message queue 2, or vice versa. This allows you to get a single source of truth on all of this. So these are the things I think everyone should know.
I think you covered all of them. Loved it.
So let's talk about how to get you started. We've actually, to ease you into this, we've built an IoT solution based off of a lot of how our users are using the system. And so you have the ingest piece in the top left corner where you're coming through IoT Hub and shoving the data into Cosmos DB. We're showing you how to do the hot store, cold store pattern and run an Apache Spark job to do things like predictive maintenance on the bottom left, and shove that into something that can do real-time scoring in AKS and have a web app in that top powering off of it. We also show you how to do that event sourcing in the bottom right. So if you want to do some stream processing through Stream Analytics and power a Power BI dashboard, or send email alerts when things like, hey, the temperature is off, we can use Logic Apps for that.
Love it.
So go to aka.ms /CosmosDB-Labs. What was the URL again? CosmosDB-IoT-Lab. And what you'll see is we'll have a GitHub repository. If you go to the IoT Lab, we actually show you step by step how to build this solution.
Awesome.
Yeah.
Like, what are you waiting for? Andrew, that was a very fast dump of a lot of information, but very valuable for our IoT developers out there. So bring back the link real quick.
Sure.
So that's aka.ms/CosmosDB-IoT-Lab. That's your next step to learn even more about Cosmos DB. Andrew, thanks a lot for joining the IoT Show.
Awesome. Thanks for
having me.
having me.
Hope to see you soon again.
And thank you for watching.